The following presentation documents the IVV plan for the EC Tracker, which is a web application that's being developed by the University of Texas at El Paso's Enterprise Computing Department. This presentation will be presented by Group 2, which consists of Paul Adame, Gary Adams, David Estrada, Luis Ochoa, and Jorge Zuversa. The presentation of the IVV plan for the EC Tracker will follow this basic outline. First, we'll start with an introduction where we'll talk a little bit about the EC Tracker and enterprise computing and how that department fits in the university. Next, we'll talk about the web application itself and describe some of its system requirements and its functionality. Followed by that, we'll go into the VVT processes where we'll analyze risks and integration and the activities that will be involved with testing plans. Then finally, we'll talk about our conclusion for all of this process. So this IVV plan will solely be constructed for the Enterprise Computing Tracker, or the EC Tracker. This is a web application which is being developed for the Enterprise Computing Department within UTEP. The Enterprise Computing Department develops many business applications that are dispersed around the university to handle specific functions for the university. Each web application has its own specific system requirements and its own customer. And it's designed for a specific reason with due dates and can quickly become complex if not managed properly. So the EC Tracker itself is a workflow manager to help create projects and set due dates and assign tasks between developers and managers that are involved in the creation of these products. So to summarize, the EC Tracker is a web application that is used by managers, external users, and internal users of the university to ensure project deliverables are met within scheduled times. Developed projects can easily be tracked by all users and assigned within them so that workflow is maintained and so that the manager can always have control of the project. The impact of this application would help streamline workflow projects where sometimes information can get lost between process areas. It also helps to provide accountability as to who's working on the project and what deliverables they've met and when it can move on to another process area. And it also will provide accurate updates between everyone across the university that's interested in the application. There are three main users. There are three main users that can be associated with the EC Tracker, and they're divided up into the following roles. First would be the manager, who is the administrator. Here, most of the functionality of the application will reside. The manager can assign projects, set up start and due dates, provide their own updates, and then assign responsibilities between internal users. Next would be the internal user, which would consist either of the architect, the developer, the designer, or the tester. And each would have their own process area. And as they completed tasks, the completion of the project would increase and it would be passed between each process area. Next would be the external user, who's the customer. The customer can log in and see the progress of the project and also see any updates that the internal user or the manager feels is relevant for them to see. There are a lot of system requirements associated with the web application, and rather than go through a long list of requirements, it might be quicker and easier to look at if we show you each user view. So first up is the manager view, and the manager would entail most of the web application's functionality. In this case, the manager would log in, and it would be able to see. They would be able to see uh, the titles of each project on the left, which ones are in progress and which ones have been recently completed. In the middle, the progress bar based on the process area, which is displayed to the right of it, and then have some options to begin a project or add a new project as they see necessary. So the manager can click on a project title. In this case, it'd be test project, and then that would open up more functionality associated with it. Here, the manager can see all updates associated with it, uh, what updates have changed, how it's gone through each process area. Uh, they can also assign it to a different user, change the project status themselves, change the priority, completion date, and then also get in contact with whoever the internal user or external user that it's currently associated with without having to go back and look through documentation. It's all there, displayed for them and easy to access. Next would be the display of the internal user. And the internal user would handle its own process area. In this case, the test project is in internal testing itself. So as it completes certain testing processes within the department, it can get closer and closer to passing that on to the next process area. Which, if we follow the list, that would go directly to the manager, and then the manager can review whether the project meets standards and is 100% to let go to the customer. This would be the view of the external user, and the external user is it's real basic. They won't have access to much of the functionality. It's pretty much just view only. But as they log in, they can see how their project is progressing, and then beneath that, see some updates if they're provided by the manager and internal users. But this would help to cut down on a lot of meetings, a lot of back and forth where a lot of time gets lost in trying to ensure that they're kept in the loop.
In the next several slides, we will discuss key terms. The objective is to describe definitions and acronyms so as to bring all parties involved with the EC tracker on the same page. This will also serve to better facilitate communication and collaboration between stakeholders and all team members involved in the project. The definitions include EC. This stands for the Enterprise Computing Department. This is a branch of the Vice President for Information Resources and Planning Administrative Division here at UTEP. Internal testing. This is a phase of the project and development that is being analyzed only by people who are working on the project's development. At this point, in this phase, no external testing by any external parties is involved. Web deployment. This is a step of a service enabling data into the web space for different levels of use. Access control. This is a feature designed to enable only certain users to access the project's data. Workflow management. This controls how the project's content is published by following a series of steps. Web-based. This is a management software implemented as a web application to be accessed via a browser. Project planning. This refers to a process of scheduling, and this process acts as a branch under project management. Acronyms. EC, Enterprise Computing. IPMA, International Project Management Association. CBA, Cost Benefit Analysis. SysRS, System Requirement Specification. VVT, Verification, Validation, and Testing. Risk management. The objective is to explain that there are a number of risks associated with the EC tracker. When discussing any web application, the largest risk to overcome and achieve is security. There's always constantly newer and more adaptive ways for breaches to occur, forcing technologies to ensure flexible and mature countermeasures, regardless of its complexity. Therefore, we will analyze these as risks and the risk table. Risks. Risk 1. Security breach comprising employee information. The application will require credentials to log in that are tied to staff information, such as username, employee info, and etc. Risk 2. Disclosure of information between application roles. Application roles should hide certain information between external and internal users, to include that of an internal user and a manager. Risk 3. User functionality issues. User encounters bugs while working on the application in the production environment. Risk 4. Application functionality issues. Application crashes or major bugs are encountered while the user is working on the application in production. Risk 5. ADA compliance audit. Application must adhere to the university rules to be ADA compliant as per state and federal guidelines, as well as some that have become laws. Risk 6. System outage. Environment is down and the application cannot be accessed. For example, internet outage, network crash, etc. Risk 7. Infrastructure misconfiguration. Misconfigurations of the application server as well as the database and database platform are recipes that allow the application to be exploited, especially when implemented with the known default settings. The exploits can be externally varied due to many of the known configuration patterns. Risk 8. Insufficient transport layer protection. Applications that do not authenticate, encrypt, or protect confidentiality and integrity of sensitive network traffic by proper use of certificates allow for the possibility to intercept network traffic by an untrusted party. Risk 9. Unvalidated redirects and forwards. This allows attackers to direct the user to a site they did not intend to go to and perhaps ask for personal information by tricking the user into thinking that they are at a valid, familiar, and trusted site. Risk 10. Access control. In the event that access control is not secure, then high-level security data can be accessed by unauthorized users. Now we will move on to explaining the risk table. It is comprised of the aforementioned risks as well as the risks' respective anticipated VVT cost as it appears in the risk table. The risk table is made up of identifying the risk, providing a value for its failure rating, providing a value for its severity, multiplying these two values to get a total, which will then allow you to make an assessment for the VVT cost, the appraisal cost, impact cost, and the total cost. So for example, with risk 1, as we can see in the table, it has a failure rating of 5, 5 being the highest, 1 being the lowest. The severity has a value of 10, 10 being the highest, 1 being the lowest. Multiplying 5 and 10 gives us a total of 50. The VVT cost, then, is the cost of testing university single sign-on and application for security vulnerabilities, reevaluation of software standards. The appraisal cost is the cost of implementing new security software suites, network tests, project workload, scheduling, and the impact is the cost of loss of employee information and breach of information. And the total cost gives us time, labor, information, security, and development. This same pattern continues in risks 2 through 10 with their respective values and assessments.
Verification, validation, and testing evaluation. The purpose of VVT evaluation is to make sure that a system satisfies the specifications and intended purpose. We can ask the following 4 questions to evaluate a system. Does it solve the business problems? Did we build what the customer wants? Are the quality standards met? Does the system complies with the specifications? If the questions above are true, then it's implied that the right system was built and the system was built right. Validation, verification, and testing qualification. In order to assure the quality of a system, we need to perform operational tests on the system, in this case the EC tracker. 2 common tests in order to assure VVT qualification is black box testing and white box testing. In black box testing, we test the system as a whole. We don't have any knowledge of the internals of the system. In white box testing, we test the internal structures and we are fully aware of the internals of the system. In this slide, we're gonna show an example of black box testing. Requirement EC21 states that the user shall log in to the web application with the UTEP credentials. In order to meet this requirement, a tester must submit the login credentials. Then the credentials would be sent to the authentication system. Then the authentication system must decide if the credentials are correct or not. If the credentials are not correct, the user would be redirected to the initial login screen. On the other hand, if the credentials are correct, the system should authenticate the user and let him pass through the system, redirecting him to the dashboard. As you can see in the diagram, there's no need to see the internals of the system. We only need a set of states and actions. Black box testing has both advantages and disadvantages. 2 of the key advantages, it's 1, it's not necessary to read code. 2, we experience the real user's perspective. The main disadvantage of black box testing is that we lack of testing coverage. In this slide, we're going to show an example of Whitebox testing. The example, it's going to be the same one for the previous slide, where the user shall log into the web application with UTEP credentials. Two test cases are derived from that requirement. In the first test case, we want to make sure that the user is able to authenticate with valid credentials. The following piece of code is the test case for that scenario. First, we create a mock database for testing purposes. Next, we create an authentication service that's linked to the database we just created in the previous step. Then, we create a user to be tested with the required username and password. Finally, we call our authentication service to do a login for the user we just created with the correspondent password. If the authentication service returns true, it means that the user successfully logged in to the application. Therefore, the test has passed. The second test case is that the user shouldn't be able to access the application with invalid credentials. This test case is very similar to the previous one. First, we create a mock database. Then, we create an authentication service linked to this database. Then, we create a user with a username and password. Finally, we log in our authentication service, but instead of providing the correct credentials, we will submit an incorrect password. If the authentication service returns false, this means that the user could not log in with the provided incorrect credentials. Therefore, our test passed. As we can see, Whitebox testing provides the internals of the application. We have more information available, but requires technical.
In closing, Group 3 went ahead and thoroughly explained what the Enterprise Computing Tracker would be, what it will do, and who will be using it. Then we transitioned into explaining the IVV plan for the EC Tracker. We went ahead and explained the system overview and system requirements. Then we transitioned into explaining the risk management, its methods and tools that we use to implement it. Then it was followed by the VBT evaluation and a thorough explanation of the VBT activities and qualifications. Thank you for your time.